We need to figure out how to actually find coterminal angles. And I feel like, Olivia, you mentioned yesterday you understood what they were. It's probably hard to actually figure out what those angles are going to be. Here's our rule. To find coterminal angles, and this is what you're going to write on the bottom of page 7. Sorry, I think I said 8. I actually meant 7. To find coterminal angles, all we need to do is add or subtract multiples of 360. Our rule is to find coterminal angles, all we need to do is add or subtract multiples of 360. So again, we're on the, is the bottom of page 7? Yeah. Bottom of page 7. Our rule for finding coterminal angles is we are just going to add or subtract multiples of 360. 360 because that's how many degrees it takes to go one time around the circle. So if I want to find a positive angle and a negative angle that are coterminal with negative 45 degrees, we're going to start with negative 45 degrees. I am going to be looking for a little bit of work with this, not like a whole lot of work, but our rule says, what do we have to do?
Add 360.
Add 360. So do that. And the work I need to see, this is like really easy work. You're going to write down negative 45 plus 360. And then you're going to figure out what that is. You may use your, you may, although I feel like when this ends up on a quiz, it'll probably be on a non-calculator part of a quiz.
Oh, no, I'm going to make bad mistakes on that.
We should be able to add some numbers together. Negative 45 plus 360, let's go, please, quickly.
315.
315 degrees?
Yeah.
Negative 45, if you were to graph that, and 315 would end up in the same place. You're getting there in different ways. Negative 45, you're spinning clockwise. 315, you're spinning counterclockwise, but you're going to end up in the same place. But the direction was I want a positive angle and a negative angle. Well, how can you find a negative angle that's coterminal to negative 45 degrees? Kevin?
Subtract 360.
Go do that. And that will find your negative angle. We already have negative 45, so I'm not kind of including that. I want another one that's positive and another one that's negative.
For which answer?
So negative 45, start from that again, and...
Oh.
And go.
So basically you add.
Right, when we're doing a negative minus some number, you do add them and make the answer negative. But your answer should be negative 405 degrees.
So you need both those answers?
The direction was find a positive angle and one negative angle. So yes, we do need both of those. Is it possible to find any other positive angles, though?
Yeah.
Like how?
Well, just add
720.
Yeah, well, or we could take the 315 and add another 360 to that, which is like taking the original and adding 720. We can keep doing this. Our rule didn't just say add or subtract 360. It said multiples of 360, which just means we can do this as many times as we want. I would like you to try letter B. And again, I would like one positive and one negative coterminal angle. Letter B. 395 degrees. Find a positive coterminal angle and find a negative coterminal angle. We should be finding some coterminal angles right now. That'll mean writing something down. And again, I do want to see the work, not a lot of work, but show me the addition or subtraction problems. Because I'm asking you to do so. And you don't want to lose silly points on your next quiz for not showing me. Allie, do you have a positive angle?
755.
Absolutely. We can add 360 degrees. Did anyone find a positive one, though, by not adding?
I did.
Kara?
Yeah, I did.
What did you do?
Minus 360.
I found out.
First, okay, so I didn't actually realize this one was going to show up. Yeah, what Allie said is perfectly fine. Add 360, 755. You could have added another 360 if you wanted to, find another one. But we could also subtract 360, and we're going to get 35 degrees. Are we done?
No.
No, so Olivia Salkin, what are we going to do?
So you have to get the directions where to find one negative angle.
Okay.
So you can take the 35 that you got and subtract 360.
Sure, let's just take that answer, subtract another 360 from that, and we're going to get negative 325 degrees. Does this make sense? Okay. What I would like you to try now, on the next page, you're going to... We done? I would like you to do a couple things. So first you're going to review what we did yesterday. You're going to draw those angles in standard position. Remember that just means the initial ray. Where is the initial ray? Always.
That.
Like between 1 and 4 positive.
The positive x.
On the x-axis.
Positive x-axis, yes. So then you're going to spin. You need to make sure you include the direction of how you were spinning and an arrow and all that. Draw them. Then find a positive and a negative coterminal angle. Just draw the original and calculate the positive and the negative coterminal angle. Take a couple minutes with this without talking. We can hold it together for this last 45 minutes. We can. So again, we should be looking at those problems on page 8. Again, not just sitting there. The 45 minutes will go a lot faster if you're actually doing things. It really will. Not, I'm assuming you're doing things.
Wait, all 4?
Yeah, you're going to do all 4 quickly right now. Thank you. Thank you very much. I appreciate it. Yeah, I did. Mr. Masovsky will tell you guys at 1:52 or something like that.
Wait, what?
Right. So she'll sit in suspense for 40 minutes while she's drawing angles and finding coterminal angles. Go draw.
That's not a productive
Shh. Oh, let's go.
I'm trying.
That's right.
Make sure you're showing the calculations for the coterminal angle part. Add 360, subtract 360. Didn't I say we were going to do that next week? Because I need some time to think through things.
Oh, I thought you
This
said
class is very challenging to figure that out in.
I'll take Windows C.
Okay. Are we done? Because we're obviously all talking.
Yes. Yes.
I see some people still working. So, hush.
I have a question.
Question, Olivia.
Okay, for D, this is what I was wondering yesterday. Like, we have to draw the squiggles and stuff.
Yes.
That's gonna be a little.
Yeah. Because I need to see like how many complete times around have you gone before you end up.
Could you see what I did and see if that's correct? 'Cause I'm not really sure.
Perhaps.
Because like I did 1 circle, 2 circles.
Yeah, I think that's fine. Just gotta make sure the arrow actually ends on the like spiral rather than on the end. I need
okay.
to actually see an arrow. Okay, let's take a look. 65. I don't think 65 degrees is a big deal. Hopefully you ended in the first quadrant, maybe a little closer to the positive x-axis. 65 degrees should look like this. Melanie, what's a positive coterminal angle?
425 degrees.
Oh, and I guess it's going to show us the other one at the same time. Negative, did you get negative 295?
Yeah.
Let me explain why we have this rule of add or subtract 360. We're over here at 65, right? Isn't 360 one complete time like a round circle? So if I go to 65 and then go all the way around, wouldn't that put me ending up at the same place?
Yeah.
If I subtract 360, that's just going all the way around, spinning in the other direction. That's why all we need to do is add or subtract these things. Paul, what quadrant was B in? That looks good, yep, 230 degrees over there. And you have the two coterminal angles. I think that sounds good. Yep, add 360 degrees, you're going to get 590. Again, just make sure you're putting those degree signs on there, because once we start radians, which will probably be a little bit later today, that will mean something different. And subtract, you're going to get negative 130 degrees. And can you wait till whoever just left comes back? Negative 130 degrees over there. Can we get those? Leah, what quadrant did you get for C?
4.
I don't agree. It would be if it was 300 degrees.
Round 1.
Oh, okay, 1.
Quadrant 1. So we're dealing with negative 300 degrees. We're going to spin the other way, and we're going to end in quadrant 1. Matt, do you have the coterminal angles?
60 and negative 760.
Good. Add, you're going to get 60 degrees, the positive one. Subtract, you're going to get, did you say negative?
I'm at 60.
660 degrees. Good. Bo, put that away. Letter D. Afra, what quadrant did you end in for D?
I know. Would it be the 2?
Quadrant 2? Good? Olivia.
I get confused. I said quadrant 1.
She said 1.
I
said 1.
Yeah.
I think it's 1. So watch what's going to happen. We're going to go all the way around once, twice, and a little bit more. 360 is one time around. How many degrees in 2 times around?
I can't do this with you.
Okay, first of all, they shouldn't look like squiggly things. I just couldn't do like a nice, clean spiral thing. But we're going around once. And again, how many times is 2 turns around, Kevin?
720.
720, 360 times 2. Then I need to get to a little bit more to get to that 740. No, they shouldn't look squiggly like that, but they should be like spiral things. Kevin.
So, question about spiral drawing abilities.
Yes.
So, on my spiral, you outside and one in. Would you rather inside out?
Yes.
It's actually a legitimate question, too.
Usually, yes, because it's like as you're spinning around, you're going a little further out.
Yeah.
It's
Yes.
like centripetal force.
Sure.
Alright, let's
Okay, we're getting off topic and distracted and
It might be centripetal.
Yeah.
right. We're okay. Kevin, do you have the coterminal angles?
I do have them.
What do you have?
Okay, I actually did not do that.
Benny, do you have the coterminal angles?
For positive one, I had 1,100 degrees.
Yep, you can add 360.
And then for the negative one, I have negative 340.
Oh, okay.
Good. Does anyone have any other positive ones?
Well, I have
380 would work, or 20 would work.
wait, that's what I did?
So subtracting 360, we've got 380, that's okay. Do it again, you've got 20, that's also okay for the positive one. I think in general, I'd actually rather prefer like the smallest possible numbers. So I kind of prefer the 20 and the negative 340, but I would take anything.
Would you get points off?
I will take anything, but I'd prefer, and we're going to actually see the most useful ones for us moving forward with things will be the smallest numbers. Okay.
That's what so, never mind. Right, never mind.
Were you about to say you did subtract 360?
Yeah, I did 20 degrees and then I wasn't sure.
Sure. And then to get the negative one, subtract 360 again. Just take that answer, subtract 360. Any questions on this? Can we draw and find coterminal angles? And again, how many angles are coterminal?
Infinity.
Yeah, well, we were just giving 2 answers here, but can't you just keep spinning around as many times as you want? Okay. So we now need to start talking about something that's going to be a very big deal for the rest of the unit. And those of you taking pre-calc next year, you will basically be using this at least half the year. This thing called the unit circle. Okay. This is not going to be bad. We are actually going to create two different circles, showing us certain very important angles that we're going to use later on. Remember on the first day I told you like sine of 30 degrees was 1/2, and why is that true? Well, we'll get to that later. This is starting to get to why we care about that. We can't actually answer that question until after break. But here's the deal. I have my circle, and I'm going to draw in all the angles that are multiples of 30 degrees. I'm going to start over here having spun not at all. If you don't spin at all, how many degrees is that?
0.
0. Right next to this, just label that as 0 degrees, please.
-0.
0 degrees. Then, every tick mark, or really like every radius coming out of this thing, is another 30 degrees. This one over here, if I spin and end up over there, that will be 30 degrees. And what's the next one? 60 degrees. And what's the next one? 90 degrees.
120.
And then 120 degrees.
150.
150. You know what? Go do the rest quickly on your own. All we're doing is adding 30. And you know what? When you get back to 0, maybe give that another name as well.
-0.
No.
I don't know anything other than...
You'll figure it out when you get to the one before and have to add 30. Shh. Kevin.
Have our stapler?
No, we're not. We should need to be filling in the circle right now. Put that away, please. Put that away, please. You can deal with that later.
Put this one away.
Put all of them away.
Find some.
I did some adding wrong.
What's after 150?
180.
Which I feel like should make a whole lot of sense because we spin halfway around. We're at 180. Next.
There's
210.
210. Then.
240.
240 degrees. Then.
270.
270 degrees. Then.
300.
300 degrees. Then.
330.
330 degrees. And then, what would the other name
360.
be? 360 degrees.
Oh my gosh.
Yes.
Do you want us to keep going?
No, so we're just going to do all the angles from 0 to 360. I realize technically there are infinitely many possibilities here. These are going to be the most important ones. The reason these are important, we will see after the break, but it will have something to do with figuring out sines, cosines, and tangents using things about 30, 60, 90 triangles. More with that after break, though. I now want to do the same thing on the other circle, but here we're going to do multiples of 45 degrees. We're going to start with 0 degrees.
or to split a pie.
What is our first angle? This is easy.
45.
45 degrees. Go do the rest. Shh. We need to be a little more focused, some of you.
These are weight units. Yeah. No, that's still. I'm not the same.
After 45 is what?
80.
45 plus 45 is not 80, it's 90. After 90?
135.
135. After 135?
180.
180. After 180?
225.
225. Then? 270. Then?
270. No, 350.
315 degrees. And then, just to repeat it, 360 degrees. Okay. Now, when we deal with this thing, so all multiples of 45 here, and these will be useful because we know some things about 45, 45, 90 triangles, and that'll be helpful again after break. These are not actually the unit circle. The unit circle actually involves putting these things together in one combined circle. Okay, watch really closely. I hope this works. Watch closely. We're going to put them together.
Oh.
And there we go.
It hurts my brain.
I would like you on the bottom circle to fill in all these good angles. The angles that are multiples of 30 and the angles that are multiple of 45 all together. Where we are going with this These are very important angles that we're going to be working with. You will need to be able to locate any one of these angles very quickly around the unit circle. So like 225 degrees, it's in quadrant 3, it's the one directly in the middle. 210 is in quadrant 3, but it's the one closest to horizontal. Fill in all of those on that unit circle, the combined one, on the bottom of the page. Let's save that for later. Your story.
My story?
Just tell me if it's
No,
Story time?
I can't tell if you're here or not.
you're not in trouble this time.
Okay.
The other two.
Yeah.
Oh my gosh. Okay, do you have that unit circle filled in? The first thing we're going to have to be able to do with this is, whoops, okay, there. I guess I should have moved earlier because now it's in the center. First thing we have to be able to do is just locate certain angles. Forget about C and D right now. A and B, I would like you, you know what, just to put a dot at that place for that angle. So on the next page. You have small unit circles. I would like you to figure out which of these marks is where 150 degrees is, and just put a circle there. Okay.
I really just.
Does your page look different from mine? No. On the next page, letter A says 150 degrees. All I want you to do is find that. Which of the tick marks around the circle is that? And put a circle there. Put a dot there.
I know that.
Is it this one?
No.
This?
No.
This?
Maybe.
No.
Tell me when to stop.
No.
Stop. No.
No?
One more.
Yes.
Yes.
150 degrees?
Yes.
Oh, I guess it is going to spin, but that's okay. It's, all I'm really looking for is a dot there. That's good enough. And your angle is over here. Please locate the next one. Locate 315 degrees. Don't do C and D yet.
Oh, do it. Going this way. What?
Ethan, what quadrant are we in?
Thinking.
Oh, for B.
For B.
270.
4. Now, in quadrant 4, are we the one that's close to horizontal, close to vertical, or the one right in the middle?
No.
315 is the one right in the middle of quadrant 4. Yes, we can locate these.
C.
For the negative ones. Well, we didn't put negative things on the unit circle, but we can still figure this out. You know that 30 degrees is the one right above horizontal in quadrant 1. So how are we going to get to negative 30?
Same thing.
Spin the same amount, but in the opposite direction.
Oh.
That's it.
Crazy.
Basically, you figure out what 30 degrees is. I really think we should remember that talk from 2 days ago about how like this is a really tough unit if you're not focused. I feel like some of us are not super focused right now, which is going to make this really tough. Negative 30 degrees is over there. For letter D, locate 120, and then you're just going to spin the same amount in the opposite direction to get to negative 120.
Done.
Paul, what quadrant are we in for negative 120?
We're in a circle. We're on the quadrant.
Three.
Okay. In 3, is it the one right in the middle? Close to horizontal or close to vertical?
That one?
1, 2, or 3?
Doing 3, yeah.
Wait, what? 120?
No, I got the one in the middle.
I got
Oh.
Okay.
2.
Because you did positive 120.
Right.
Did you end up over here?
Yeah, but I thought
Whoa, hold on, listen. Excuse me. So that would take you to positive 120. I want to spin that exact same amount, just in the opposite direction. So I'm going to start over here, and rather than spinning like this, I'll spin the other way down there to make it a negative 120.
Oh, that's what I did for some.
Questions on these? Okay, so this is everything we need to know about degrees. But there's another way to deal with angles as well. And these are called radians.
Oh.
Our
I
definition.
actually have to write stuff, don't
A radian is a way to measure angles, like degrees, that will somehow relate the measure of an angle to the length of the arc along the circle that's traced out. Copy it down, I'll explain it all in a moment. A radian is a way to measure angles, like degrees, that relates the measure of an angle to the length of the arc along the circle that's traced out.
You read really fast.
A radian is a way to measure angles, like degrees, that relates the measure of an angle to the length of the arc along the circle that's traced out. This will make sense in a moment, I promise.
Related to a radiant.
What?
In case you can't see.
Uranium.
What?
Wait, what?
I'm confused.
Never mind. No, radius. That's what I was trying to say.
It will have something sort of to do with that. It has something to do with...
I don't even
Is
know.
anything beginning with makeup term for
Ah.
anything?
No.
It's all term for?
What?
Yes.
Okay, good.
Hablo inglés.
Okay,
Hablo español.
so here we go.
No. Wait.
I didn't mean to say that.
Good. I realized that I was one word away from finishing.
So here's the deal. First of all, we're going to get several bullet points on the side of that circle picture that you have in the notes. First of all, yeah, and again, here's where we are going to need to be focused. If we're focused, this is not going to be a big deal. If you're not, none of this is going to make sense, and this is going to throw away the rest of the units. So you really need to focus.
How are the people who are not here gonna know?
It's like a video, come on.
That's why we're doing that.
Sorry.
First, we are going to deal with angles around what we call the unit circle. And the reason, we already kind of mentioned the unit circle, but the reason it's a unit circle is because it's a circle with a radius of 1. That will be important. We are dealing with angles that are around this unit circle, a circle with a radius of 1.
So like those lines are one.
Yes.
Okay. Okay.
One.
And I could put in like the other lines like we had in the last couple pictures, the one here, they're all radius of 1.
Okay.
Now, one complete spin around this circle, one complete spin, which is 360 degrees around, my goal is to relate the angle to how much of the circle is traced out. Well, if you go all the way around, how much of the circle did we trace out?
360.
How much of the circle?
The whole
Oh.
The whole thing. My goal was to relate the angle to how much of the circle is traced out. Well, didn't we trace out the entire circle, which is the entire circumference of the thing?
There's one radian.
Hold on, it's not. Hold on a moment. One complete spin around, which is 360 degrees, has an angle measure that is equal to the circumference of an entire circle. What is the formula for circumference of a circle? It is not pi r squared.
Okay,
What,
What's the formula for circumference of a circle? I just said it is not pi r squared.
Good job, tutor. 2 pi r.
Does it have 1.5?
2 pi r.
2 pi r, or there is another version, the pi times diameter version. I'm going to go with 2 pi r. Circumference is 2 pi r. But what is the radius for this circle?
I don't even know.
Uno.
Why is it 1?
Because.
Because it's always 1 because we're calling this circle our unit circle.
So can we just say
So like a-
So hold on. So our circumference is 2 pi times 1. Going all the way around is an angle that is equal to 2 pi radians.
Is like unit circle like parent function kind of? Like are we ever
Sort of. No, we're always dealing with the unit circle.
Okay.
Radius will always be 1. Going all the way around is 2 pi radians. Can I think if I push enter? Yep. So we're starting at 0. If you go all the way around this thing, we can call that 2 pi radians. Benny?
Do you ever want to multiplying that by pi or just keeping the symbols?
No, so for maybe later. For right now, I want exact values. So you're going to call it 2 pi and just leave it at that. Don't give me a decimal for that. Now,
Is this the huge
Is
sum with all the pies?
the
the
2
fractions,
pi,
and the-
2 pi. Wait,
Casey.
the 2 pi is
2 pi.
No way.
Okay, no, I need you to listen. Don't go anywhere at all, that's 0 radians. If we go all the way around like 360 degrees, we can say that is 2 pi radians.
What?
This is
Why don't we
confusing.
write 2 pi? Oh, because it's.
wait.
Okay, one more time.
I think I'm
Going, this is again that I need you to focus thing.
I just saying.
Listen one more time. Going all the way around the circle is 360 degrees. If we go all the way around, doesn't that mean we've traced out the entire circumference?
Yes.
What is the circumference of this circle? 2 pi times 1, 2 pi. Going all the way around, we are going to call 2 pi radians.
Okay.
We can figure out every other angle based on that. So think for a moment. If going all the way around counts as 2 pi radians, how many radians do you think it will take to go halfway around?
1.
One
Pi.
radian.
1 pi.
I want 1 pi.
What's a radian?
Please listen again. All the way around is 2 pi. If we only do half of that, isn't half of 2 pi just 1 pi? Divide 2 pi by 2. Halfway around the circle is pi.
It's just pi.
It's just pi.
Forever.
Olivia.
So does that mean the angle in between 0 and pi would be 1/2 pi?
What do you think?
Yeah.
Sure.
Sure. If an entire spin around was 2 pi, so half of a spin around the
Yeah,
circle
okay.
is 2 pi over 2, or pi. A quarter of a spin around the circle, so basically half of what we currently have, would have to be pi over 2 radians. So that one up top, pi over 2.
3 halves pi.
Bo thinks the other one's going to be 3/2 pi.
No. Yeah.
Well,
No. 3/4.
Matt agrees. Kara thinks 3/4.
no, 3/4.
Okay,
It's 3/4.
to find the remaining one, would you agree that to get over here, that's like saying, let's do a half of a circle and then a quarter of a circle.
Yeah.
What's half of our circle?
Pi.
Pi. What's a quarter?
Is it
Pi
3
over
pi over
2.
4?
Pi over 2. So wouldn't we have to do pi plus pi over 2?
Which would equal
3 pi
pi
over
over 3.
Okay, so 3/4 of a spin must equal pi. Okay, hold on a moment. Yeah, I know. Hold on.
Oh, that is not.
Oh, fancy.
Okay. We can change this.
See, every time I get into
That's
something, I always like freak out.
Nope, that's not what we need. Exit this.
Image.
Yeah.
Right in.
Nope. Okay, hold on. Exit that again.
I think we should just all stand up and look.
No.
That's actually not a terrible idea.
Beep, 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 beep.
Because
No, oh, you just had it. Cinema.
Oh, ah.
Okay. 3/4 of a spin has to be pi over 2 plus pi.
Oh, wow.
Well, we would need to get a common denominator to add those. So we'll say pi over 2 plus 2 pi over 2, 3 pi over 2 radians.
I was like, wait. Oh, I'm getting this.
Question, Kara.
Oh, I got it now. No, I'm not even kidding.
So right now we have a total of like 5 angles that we know the same thing in degrees and radians. Don't spin anything that's 0 degrees, that's 0 radians. If you spin 90 degrees is what in radians?
2.
It is not.
No, I mean
Pi over 2.
Pi over 2. If you spin 180 degrees, what is that in radians?
pi.
Pi. If you spin 270 degrees, what's that in radians?
Pi over 2.
And if we spin all the way around 360, which is where everything started from, we say that's what?
2 pi.
2 pi. Are you with me so far?
Sí.
Do I need to try any of this again?
No.
There are more angles, though, that we need to be able to deal with. The unit circle in radians are multiples of 30 degrees. Okay, so... Oh, no, didn't want that yet.
1/3
Okay,
over pi
so-
over 6.
Watch, please.
Oh, God, I know this.
I want to figure out what my multiples of 30 are going to be. I know... No, I still need you listening. What angle do I have up here? Pi over 2. Now, isn't each of these like a third of that? This is 90 degrees. Isn't 30 degrees a third of 90? So wouldn't this have to be a third of pi over 2? Write down 1/3 times pi over 2 and tell me what that equals. 1/3 times pi over 2 will tell me what 30 degrees is in radians. Pi over 6.
Pi 6.
30 degrees is pi over 6. I can label this angle as pi over 6. Here's where the radians get really nice, and why these are going to be very useful, and actually in some ways a little bit easier to work with than the degrees. 30 degrees, each of these tick marks is another pi over 6. So like, how many pi over 6s is this one?
Pi 12.
That in a moment. How about we just say this is like 2 pi over 6? We'll simplify in a moment. That's 2 pi over 6. What's the next one? Don't simplify.
Pi over 2.
Again, don't simplify yet. We'll simplify later. 3 pi over 2. Do you see how we would continue getting the rest of these? Oh, sorry, 3 pi over 6. Thank you. Do you see how we would continue to get the rest? Fill in the rest. Don't simplify any fractions yet. It's just another pi over 6 every time.
Oh, I see how that works out. Cool beans.
We should have 4 pi over 6, 5 pi over 6, 6 pi over 6. Yeah, I know we can simplify. We'll do that in a moment. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6.
How do you not get your tongue twisted doing that?
Questions on how I got those? What's wrong that some of you have already been mentioning? Simplify. Can you simplify pi over 6?
No.
Can you simplify 2 pi over 6?
Yes.
What does 2 pi over 6 become?
Pi over 3.
So simplify that as pi over 3. Okay, let's see. Perfect. 2 pi over 6 becomes pi over 3. What about 3 pi over 6? Pi over 2. Why do I feel like that makes perfect sense that this is pi over 2? That's where pi over 2 is, right? From the 90 degrees is pi over 2. Take a moment. Go simplify everything you can. You can't simplify every one of them, but you can simplify many of them. Simplify what you can simplify.
If I don't have space,
Write small.
okay. Figure it out.
I do think it will be helpful to have both the original and the simplified version. We're actually not really going to use the originals much beyond this. We're only going to use the simplified versions.
Okay.
But I think it's easier to see where it comes from if we use the original ones.
Go on.
Olivia White, could you simplify 4 pi over 6?
2
2 pi over 3. Matt, how about 5 pi over 6? No, that's the best we can do. So go on and do the next one. 6 pi over 6. Sorry, the 6 pi over 6. Just pi, which I think also agrees with what we had on the previous page. Half of a spin around is pi. Olivia has 7 pi over 6.
You can't do it.
Okay, so deal with the next one. 8 pi over 6.
4 pi over 3.
4 pi over 3. Good. Leah, how about 9 pi over 6?
3 pi over 2.
3 pi over 2. Good. Casey, how about 10 pi over 6? Bless you.
Thank you.
They're both even numbers.
5 over 3.
5 pi over 3. John Paul, 11 pi over 6? Okay, so how about 12 pi over 6? Which I feel like also makes a whole lot of sense because we already said 1 whole time around the unit circle is 2 pi. Do you see how we got these numbers? The unsimplified version I think was helpful to get these, but we're moving forward only really going to use the simplified versions of these things. And I think if I push enter, yeah, there we go. We just have the simplified versions. I would now like to redo what we just did, and then I think we'll stop after this, with 45 degrees. 45 degrees. This is pi over 2 in the box. Wouldn't it make sense to say that 45 degrees is like half of that, and half of pi over 2 is pi over 4? Pi over 2 is over here. Don't I want half of that to get me from 90 to 45? So, thank you. So half of pi over 2, pi over 4. Let's now just do what we did in the last time. If this is pi over 4, this is going to be another pi over 4. So how many pi's over 4?
Great.
No.
Over a billion.
2 pi over 4.
2 pi over 4.
What did you say?
What's the next one?
4 pi over 4.
Well, how about 3 pi over 4? Fill in the rest of them. And you know what? When you're done, go and see what you can simplify. I actually think the simplifying ones, well, you'll deal with this. Hopefully we have 4 pi over 4 and 5 pi over 4 and 6 pi over 4 and 7 pi over 4 and 8 pi over 4. Bless you.
Bless you!
Which ones can we simplify?
Well.
Every other.
So like any of the ones that are at a 45-degree angle, like halfway in the middle?
Yeah. No.
I think only the ones that are vertical or horizontal, the ones you've already dealt with before, actually. So pi over 2, pi, 3 pi over 2, 2 pi.
Yeah.
Again, well, we're only going to really focus on the simplified version. So 0, pi over 4, pi over 2, all those things. Next class, we will actually put these together in one big circle and see, are there some patterns? So eventually, we're going to have to be able to locate any of these angles. Locate like 7 pi over 4. We're going to learn some shortcut tricks for figuring out how exactly to locate those things.